All right, guys. Well, I'm not going to work through all of these problems, but sure, I will work through some of them. This was homework given on Friday if we didn't finish it in class. So that's another reason why I'm not going to work through all of them. But let's see if we can hit 50% of them. So at least you'll have 50% of the answers for your homework, all right? So starting off, it says, on a recent trip to the movies to see The Matrix, 3 students, Mark, Carly, and Rita, each spent some money at the concession counter. Okay, so even with that being said, some money, you can kind of get suspicious of what we're going to be looking for. All right. Mark bought 2 candy bars, a drink, and 2 bags of popcorn for a total of $5.35. Carly spent $4.16 on a candy bar, 2 small drinks, and a bag of popcorn. Meanwhile, Rita spent $5.85. She didn't buy any candy, but she bought 2 small drinks and 3 bags of popcorn. If all the purchases included tax, what was the purchase price for each item? So again, using that context clue, we have some money. We don't know how much each item costs. So we're looking for the purchase price of each item. Now, generally speaking, when you find that question, that's usually a good indicator of where our variables are going to go. So we're looking for purchase price of each item. So what items do we have? Well, we have candy bars. So let's go ahead and just call that C for candy bars. So candy bars, we're going to have C's. Drinks, let's call that D. And we're going to have bags of popcorn, so P for popcorn. So we know that Mark bought 2 candy bags, or candy bars, so 2C. He bought 1 drink, or a drink, so plus 1 drink, plus 2 bags of popcorn, so plus 2P. We know that's equal to $5.35. He spent $5.35 on that. All right. Now Carly spent $4.16, so we know she spent $4.16. This equation looks like it's going to be written a little bit backward. On what? Well, 1 candy bar, so 1C, 2 small drinks, 2D, and then looks like 1 bag of popcorn, plus 1 bag of popcorn. Then we have one more. We have, meanwhile, Rita spent $5.85. So again, kind of writing this one backwards. She spent $5.85. Well, what'd she spend it on? She didn't buy any candy bars, so we have no candy bars, no C's. But she bought 2 small drinks, so 2 D's, plus 3 bags of popcorn, so 3 P's. Now there's our equations. If we wanted to find the purchase price for each of these items, into our matrix, into our calculator, we'd put this matrix. We'd have 2, 1, 2, 5.35, 1, 2, 1, 4.16, 0, 2, 3, 5.85. Notice I put a 0 there instead of just leaving it blank, because sometimes people leave it blank, and that's fine. If you're good enough at what you do, you can leave it blank. But just to be safe, I put a 0 there to remind me 0 goes down here. All right? So let's go ahead and start writing this out. We got 2, 1, 2, 5.35. We have 1, 2, 1, 4.16. We have 0, 2, 3, 5.85. Now if we plug that into our calculators as a matrix, a 3x4 matrix, we should end up getting our answers. At the top should be our candy bars price, the middle should be the price of our drinks, and the bottom should be the price of popcorn. So notice C, D, P in that order. So in the order that we get our solution, it should be C, D, P, starting from left to right, also top to bottom. All right. So anyway, let's go on to the next one. The baseball shop sold 10 balls, 3 bats, and 2 bases for $99 on Monday, 4 balls, 8 bats, and 2 bases for $78 on Tuesday, 2 balls, 3 bats, and 1 base for $33.60 on Wednesday. What is the price of each ball, bat, and base? Again, in the question, we kind of find out what our variables are. We're looking for the price of the ball. Let's call that X, the bats. Let's call that Y, and the bases. Let's call that Z, okay? So we've got 10 X's plus 3 Y's plus two z's equals 99. Notice 10x, 3y, 2 z's equals 99. 10x, 3y, 2z, 99. Then we have 4x, 8 y's, 2 z's, so 4x plus 8y plus 2z equals 78. Then we have 2x, 3y, 2x plus 3y plus 1z equals 3360. And we're finished with our equations. If we wanted to solve it, put it into a matrix. 10, 3, 2, 99, 4, 8, 2, 78, 2, 3, 1, 33.60. That's what we'd enter into our equation to find out x, the price of our balls, y, the price of our bats, z, the price of our bases. Okay, so let's go ahead and go on to the next one. Now, instead of reading this whole thing, I'm just going to skip to the important parts of the information. If you want, you can pause it and read the whole thing. So the question is, if a fourth friend went to the park and rode 3 mild rides, 5 wild rides, and 8 super rides, how much money would he have spent on ride tickets? So pretty much, again, in the question, we're trying to find out ride tickets, how much those things are costing. Now, that's a little bit of a different question, but you can still see where the variables are going to be in this question. So we're going to have, let's do x again for mild, y for wild, and z for super. So this person, Travis, had ridden 4x plus 8y plus 8z. See, right here. And then 8z. And that total cost was $26 for all those rides. So equals $26. Caitlin rode 8x, 7y, and 5z. So 8x plus 7y plus 5z equals a total of $24.25. And Carmen rode 7x, 6y, and 4z. 7x plus 6y plus 4z equals 20.50. Now the question at the end, I'm just going to write it over here, okay? The question at the end is if a fourth friend rode 3x plus 5y plus 8z, how much would that cost them? All right, that isn't necessary to solve this just yet. Here's our matrix, okay? When we plug it in, we'd have a 4, 8, 8, 26, 8, 7, 5, 24.25, 7, 6, 4, 20.50. If we plug that in, we're going to find out how much it costs to ride a mild ride, how much it costs to ride a wild ride, and how much it costs to ride a super wild ride. Okay? When we figure out those after plugging in our matrices into our calculator, then we can solve x. We can plug in our x, our y, and our z and find out how much the total cost was for this person. That's how you would answer that problem. I like this problem right here. So find the measures of 3 angles of a triangle. All right, so there's our question right there. We're looking for the measures of the 3 angles of a triangle. How many angles are in a triangle? 3. How much do they add up to be? 180 degrees. So let's call those 3 angles A, B, and C. We know that A plus B plus C equals 180. See, look, we don't know how many degrees A is. We don't know how many degrees B is. We don't know how many degrees C is. But what we do know is when we add all 3 angles of a triangle up, that's going to equal 180 degrees. All right, so there's one equation. Now look, if twice the measure of the first angle, so twice the measure of the first angle, that's 2 times A, which is the first angle, and then it says plus 3 times the measure of the second angle, plus 3 times the measure of the second angle, which is B, equals the measure of the third angle, equals the measure of the third angle. And if you're confused, that's where I got this from. Twice the measure of the first, 3 times the measure of the second, equals the measure of the third. All right, and then our last one is if the measure of the second angle is 3 degrees more than the measure of the first angle. So we're comparing two variables. We're comparing the second angle and the first angle. So here's our second angle, here's our first angle. I always start it like this, and then I look at it and it says if the measure of the second angle is 3 degrees more. So which angle's greater? The second angle. B is greater. Which angle's smaller? A is smaller. Now if I want these two to equal each other, I'm going to have to add 3 to which angle? Well, A is smaller, so if I added 3 to A, it's going to equal B. And there's our equation. B equals A plus 3. Now if I wanted to put this into a matrix, again, I need to have all my A's, my B's, my C's, and my numbers lined up. So this one's ready to go. I've got A plus B plus C equals 180. This one, it's close. I've got 2A plus 3B equals C. That's not good. I need to move that C over to the other side of the equation and flip its sign. Okay? What I'm essentially doing is subtracting the C to the other side of the equation. So if I subtract C from both sides, I'm going to have a minus C over here, and that's going to be C minus C on the right, which is 0. And then this one, I have to put in the right order, so I'm going to have a negative A. I need that A over here. So minus A, I'm going to have 1B. I don't have any C's, plus 0C equals, that positive 3 stays on the right side. So essentially, again, what I did was subtract that A to the other side of the equation. Here are my 3 equations that I put in my matrices. 1, 1, 1, 180, 2, 3, negative 1, 0, negative 1, 1, 0, 3. That's what I put into my matrices. I'm going to go ahead and do, let's see, I'm going to do one more. Let's start with this one right here. Alright, so 3 kinds of tickets were sold for a concert. Main floor tickets cost $35, balcony tickets cost $25, a gallery ticket cost $15. The box office sold 475 tickets to the concert for a total of $13,275. There were 45 more main floor tickets sold than balcony tickets. How many tickets of each kind were sold? So look, there's the question, how many tickets of each kind were sold? There's our variables, alright? So how many main floor tickets? Call it A. How many balcony tickets? Call it B. How many gallery tickets? Call it C, okay? So we don't know how many main floor tickets we have. We don't know how many balcony tickets we sold. We don't know how many gallery tickets we sold. But we do know that all 3 of these types of tickets added together should get 475 tickets total. Alright, now again, if a main floor ticket sold for $35, that means for every main ticket we sold, A, we need to multiply it by 35. If we're talking money now, we need to have money on here. So $35 times the amount sold, A, $25 times the amount sold, B, plus how much did a C ticket cost? 15. $15 times the amount sold in C equals the total amount of money, $13,275. One more question. There were 45 more main floor tickets sold than balcony tickets. So we're comparing the main floor tickets and we're comparing balcony tickets. Now which one has more? 45 more main floor tickets. So A is bigger than B. So B is less than A. I would need to add something to B to get it to equal A. I'm going to add 45 to B. See, again, there are 45 more of these tickets than B. So B has 45 less tickets. I need to add 45 to B to get it to equal A. And those are our equations. If we're going to put them into matrices, we need to make sure all of our variables are on the left side, equal signs line up, and our numbers are on the right side. So we're going to have to subtract b to that side. So let's go ahead and just do that real quick, I guess. So I'd have a minus b plus 0c, I don't have any c's, equals 45. Now these right here, 1, 2, those 3 equations are the ones I'd put into my matrices. Alright, hopefully this was a little bit of a help. Think about what we're doing, okay? So ultimately you just have to slow down, read things, look at the question every single time, the question it's asking, because that's where you're going to find which variables we're trying to assign, alright? So I always looked at the question, I noted which variables, or what we're looking for, and those were my variables. So for example, how many tickets of each kind were sold? Each kind of what? Each kind of ticket. So how many main floor tickets? We don't know that, so we assign it a variable. How many balcony tickets? We don't know that, we assigned it a variable. How many gallery tickets? We weren't sure, we assigned it a variable, okay? And that's how you solve these. If this wasn't too much of a help, then you need to come into tutoring sometime. Again, tutoring Tuesday and Thursday after school, Wednesday and Friday before school. Okay, thank you for watching, and I'll see you in class.